DMVPN failure detection. In this video, I'm going to talk about the mechanism of the failure detection in DMVPN. You know that in DMVPN, we have multiple components. For example, one of them is MGRE. Another component is the NHRP and also the IGP or some other components. Here, we are talking about the failure detection, okay, with the NHRP. Actually, in DMVPN, we are using NHRP for multiple features, multiple function, and one of them is the failure detection. Let me to explain the mechanism of the NHRP in the DMVPN again. You know that here in this scenario, as you can see, we have router 1, router 2, and router 3, and also I have configured multi-point VPN or dynamic multi-point VPN between the R1, R2, and R3. Here we don't need to configure because we have learned about the configuration previously in the previous videos. Because of that, here now we have this tunnel. Here we have, for example, tunnel 0 in the NHS. You know that NHS or next hop server is equal to the DMVPN hub. Okay, and also here we have tunnel 0 in the router 2 in the NHC. NHC is the term of NHRP, but we can say DMVPN spoke. Okay, and also this is other tunnel 0 in the router 3, other NHC or the other DMVPN spoke. That's right. Now, as you can see, here we have NHRP registration request. When you are configuring the tunnel 0 in the router 2 as the NHC, okay, the router 2 as the NHC should send one NHRP registration request to the R1, and after that it should receive the NHRP registration reply. Actually, we are sending two NHRP registration requests and we will receive two NHRP registration reply. The reason is that we want to ensure that we have registered R2 into the router 1. You have seen this behavior, but let me to show you again. Okay, here we have for example, R1, R2, and R3, and I have configured before this scenario. Let me to shut down first interface of router 2. This is the router 2 interface tunnel 0. Okay, let me to shut down this interface, and also in the router 3 conf-t interface tunnel 0 shut down. Now we don't have the NHC's tunnel interface. Also about the R1, let me to shut down the interface tunnel 0 because I'm going to show you everything from the scratch. Now we don't have the DMVPN. Okay, first let me to enable the tunnel 0 of the router 1 with no shutdown command. Now here we have tunnel 0. Also let me to enable the capture in this link, okay, the link between the router 1 and router 4, because I'm going to show you the registration process. All right, look at here. After some second, I will enable the interface of router 2, the tunnel 0 of the router 2, because I want to show you the, for example, sending of the NHRP registration message. Here we have NHRP. That's it. Look at here in the router 2. Let me to show you. This is router 2. And then here we can enable the interface tunnel 0, interface tunnel 0, and then no shutdown. What is happening here? We will see NHRP registration from the router 2 to the router 1. Again, registration request, then registration reply from the router 1 to router 2, and this is repeated one another time. That's it. This is the process of the registration in the router 2. Let me to enable also the router 3. Here, router 3's interface tunnel, no shutdown. Again, here, as you can see, we have two NHRP registration requests and NHRP registration reply now for example, router 3's tunnel interface. That's it. Then let me to show you what is happening in the router 1. In the router 1 as the NHRP NHS, we will have NHRP cache. Show IP NHRP can show us that we have this information. Here, I'm going to explain a little more, okay, about this line. Okay, look at here, tunnel 0 created in this time, for example, 43 seconds before, and expire in this time. What is the meaning of this expire time? I will explain it. And also here, tunnel 0 created in this time with this expire time. I'm going to talk about these two information. Look at here. When we are sending NHRP registration requests, you know that in the NHRP registration request, we have multiple information. For example, one of them is the NBMA address of the router 2. and also the tunnel address or protocol address of the router 2. For example, here we are sending this information. You have learned about them, but I'm going to review them. We have this source protocol. Source protocol is 192.168.123.2 means the, for example, tunnel IP address. And also here we have the source NBMA. Source NBMA is the, for example, 10.242, the IP address of the source tunnel source. That's it. Okay, you have learned about them. Actually, we are sending this information from the router 2 and router 3 to the router 1. Okay, you know about the function and usage of this information. You have learned about them in the previous videos. But also let me to say that when we are sending the NHRP registration request, actually in the router 1, now you know that here we have this information, NHRP cache. Okay, as I showed you, here we will have NBMA address 10.242, and then here we have, for example, protocol address. The protocol address is the 192.168.123.2, okay, 123.2, and also NBMA 10.343 protocol. Okay, protocol is the 192.168.123.3. That's it. Okay, you have learned about them. Also, let me to say that here all of these entries in the NHRP cache, okay, are remaining, okay, for a specific amount of time, okay, because they are dynamic, not static. For example, by default, when we are sending this information to the router 1, here we will have a timeout. We call it hold time. Okay, here we have timeout of hold time for this information, and by default the hold time is 2 hours. Okay, 2 hours, or for example 7,200 seconds. Okay, 7,200 seconds or 2 hours, both of them are same. Okay, here you can see, as you can see, let me to write it here with this for example format 020000. Okay, both of them. Here also we have hold time of the 2 hours again. Okay, and this time is decreasing. For example, 1 second later we will see here 01:59. Okay, for example 59, again 58, 57, 56. Okay, and this is decreasing. Let me to show you here. As you can see, now this time's decreasing to 0. Actually, if this whole time reached to the 0, this entry should be removed from the NHRP cache. Okay, but you know that here we should have one mechanism for saving these entries when the router 2 and router 3s are available. And this mechanism is sending again the NHRP registration request. Actually, in some time we call them timeout. Okay, we are sending again NHRP registration request. For example, by default, the timeout is equal to the 1/3 of the hold time, because hold time is 7,200 seconds. We are sending in each 40 minutes or in each 240 second, okay, 400 second, okay, one registration request again. For example, you know that this time now received to the 1, okay, 21 hour 20:00, and after that here, okay, we will receive the next NHRP registration request. Assume that we have learned these 2 entries in one time, and now the time decreased to the 1 hour 20 minutes. Okay, we will receive the next NHRP registration request, and this time should increase to the for example again 2 hours. Actually, in each 40 minutes, we call it in each timeout, okay, we are refreshing the age of these entries. This is the default behavior. The first thing that you should know is that we can decrease or increase the hold time value and also registration timeout value. Cisco recommends that these times are not so suitable for our network, because assume that the router 2 is not available. Actually, assume that the router 2 failed. If the router 2 failed until 2 hours, okay, the router 1 cannot understand that this entry is not available. Because of that, it is recommended to decrease the value of the hold time from 2 hour, okay, to 600 second, means 10 minutes. Okay, this is recommendation of the Cisco. Let me to show you here. I can